there, everyone. Yeah, welcome to this webinar on the science of upland peat restoration. It's a meeting hosted by the East Midlands branch. And we've got our speakers. If you guys want to introduce yourself.
Shall I go first? Hi, so I'm Alice Whittle, and I'm currently doing a PhD with Moors for the Future in Derby Uni, looking at the impacts of different peatland restoration techniques on different ecosystem services. So primarily, my work is sort of microbial responses. Thanks.
Hi, my name is Joe Margetts. I'm a research and monitoring officer at Moors for the Future Partnership. We're one of the hosts of Alice's PhD, and we're a moorland peatland restoration organisation that has been active in the Peak District and South Pennines area for over 20 years. And during the time of doing lots of different conservation actions, we've also had a science programme monitoring the efficacy of those actions. And today we're going to be taking a look at some of the results of what we found out during that time.
Cool, perfect. So yeah, this webinar is being recorded, so they'll be put up on the CIWEM website hopefully in the coming weeks or so. So we spoke to the authors, so that will be going on to the website and YouTube. If you have any technical issues, if you need anything, just raise your hand. So, but what we'd like to do is people will use the chat feature, so any questions can be posted on the Q&A kind of section. And at the end of the presentation, we'll be taking the questions. So, Laura Flower will be coordinating that, so I need to drop off. But yeah, if you've got any questions, put that on the Q&A facility. And yes, just on the chat, anything else. So now we're of CPD. CIWEM is a chartered professional body, so you can see more information on the website. So details about membership are there. So just encourage people to go for membership. So yeah, learning opportunities are there for various applications. So CIWEM is quite a large organisation. Over 11,000 members, over 57 organisations and universities in 89 nations, so very large organisation. So we have a few things coming up. So we're hoping to have Derby San Diego Canal site visit planned in July. I think the date on there is subject to change, so I think it might be the week before or the week after, so just waiting on confirmation of that. Flood and Coast exhibition in Liverpool is 9th to 11th of June. We've got the new members weekend on the 1st and 2nd, so that's a national thing in Sheffield. Early Career Professionals Conference on the 22nd of September, and then we're going to have the Dr. Jenkins Award in Birmingham on the 23rd of September. So there's a few events coming up. If anyone would like to be involved in organising any events, then do contact themselves. That would be very helpful. So yeah, I think that is probably about it for now. Without any further ado, I'll hand you over to the presenters.
Hi there. Yes, as I said, my name's Joe, and in this webinar about the science of upland peatland restoration, I'm going to give you a bit of a whistle-stop tour of some of the activities that have been going on peatland restoration sites in the peaks over the last 20 or so years, what we know, what we're still trying to find out. And my talk this morning will be a bit of context for Alice's talk afterwards. So she's going to be delving into a bit more detail about the implications on water quality and some of the research she's doing through her PhD. So start at the very beginning. The habitat type we're interested in are blanket bogs. So these are peatlands at the tops of undulating slopes of the hills. Our area of interest is the Peak District and South Pennines, and these are really interesting habitat types. They're androgynous, which means they derive their nutrients from rainwater or other forms of precipitation, rather than from water flowing across the ground through minerals, for example. And due to high rainfall amounts, they are or should be waterlogged, and that's allowed the conditions to exist where peat can form, where vegetation is dying, but it's not decomposing at a very fast rate. And as a result, we've got this acidic habitat that's got conditions suited to very specialist species, so lots of unusual plants and invertebrates and other wildlife relying on these habitats. And they're globally rare. And I guess one of the key things that people know about peat is that it's a very good store of carbon, because you've got this material that's decomposing more slowly than it's forming. And as I said, Moors for the Future Partnership formed over 20 years ago to tackle some of the issues surrounding these habitat types in our area. So I'll quickly show you our area of interest. So you can see the dotted line is the boundary of the Peat District National Park, and the purple shape is the South Pennine Moors Special Area of Conservation. So the majority of the work that we do is within that purple shape. And one of the other reasons I like to show this image is you can see there are some quite major cities, towns and conurbations really, really close to our area of interest where these peatlands are formed. And that has caused some big problems for them. So they're probably some of the most degraded blanket bogs in the world. One of the key factors driving this degradation has been historic air pollution from the industry. If I just go back a slide, actually, we can see that we had Sheffield had a huge steel industry, Manchester with cotton, towns up to the north producing a lot of wool. And obviously this was one of the first, if not the first country to industrialize in the world. So we've got enormous amounts of coal were burnt to power this industry, lots of airborne pollution, leading to high levels of these pollutants traveling through the atmosphere and falling through rainfall onto these bogs. So things like sulfur dioxide in particular is something that sphagnum moss, one of the key building blocks of bogs, is very sensitive to. So it caused a big change in the vegetation type. Sphagnum is really important because it holds lots of moisture, and the bogs began to become drier and more susceptible to wildfires. They were drained deliberately by people as well for agriculture. Over time, access by people has increased. We've got competition from non-native plants, so things like Sitka spruce, for example, from plantations, seeding itself into these landscapes. Historically, there have been really high grazing levels as well, and then you can end up with a bare peat surface that is very vulnerable to erosion. And this is a sort of a view of what we ended up with in places in the peaks. So you can see in this example, it's almost all bare peat. You've got a tiny bit of vegetation that's clinging on, and then a sheep on top there. So really, this bare peat landscape is a catastrophe for a whole host of reasons. So you've got all this carbon that was locked up is now exposed to oxygen. So a loss of carbon dioxide through decomposition and through washing out in waterways, silting up reservoirs. So you've got the effect on the drinking water supplies. So all those contaminants from pollution, so toxic heavy metals, things like lead, copper, zinc washing out as well. And it's just not a sustainable ecosystem at all. Barely anything can survive there. And then that's not to mention climate impacts, obviously, as a source of carbon. It's releasing carbon rather than trapping carbon, which it was previously. And you can see how rapidly these landscapes were eroding. So this is a picture of one of our monitoring sites in 2011. And if you pay attention to the area that I've put the red circle around here, to the right. And if I flick backwards and forwards, you can see that's 9 years later. You can sort of see how that peat is being mobilised because there's no root network to knit it together. So it's being washed down through the stream network into the rivers and having major impacts on water quality. So as I mentioned before, at the beginning, Moors for the Future Partnership was formed to try and tackle this issue. So as the name suggests, we are a partnership. The three big water companies in the area, Severn Trent, Yorkshire Water and UU, are key partners. For obvious reasons, they've got an interest in the water quality coming off these landscapes. But we've also worked closely with others like the Environment Agency, and Natural England, RSPB, National Trust, and others over the years. And we've basically scaled up techniques to try and revegetate that bare peat landscape. So the next slide is an example of that revegetation process through time. And I'll just leave that running and let it loop round while I explain very briefly what this process is. So you start with the bare peat, and then we're spreading cut heather brash onto the top of it to provide a bit of initial stabilisation and a good microclimate for germination. And then we're spreading seeds, grass seeds mainly, including some amenity species that you wouldn't expect to find up there, and some lime to raise the pH, and some fertiliser to give them a kickstart. And if you do that, you can get a mat forming very quickly within a year. And that has an enormous effect on stabilising that surface. So it just stops that rapid erosion and allows other plants to grow into it. So I'll move on. We can see the results of bare peat restoration on Kinder Scout here after 11 years. You've got the bare peat site on the right and one of our most advanced restoration sites on the left. And this is a really interesting site. So we've got these mini catchments up there, about a hectare each. We've actually managed to keep a control catchment of bare peat where we've done nothing, which has been invaluable for seeing what the trajectory of change would have been had we not intervened. And these, in very brief overview, these are the key restoration findings from that site in that time. So we've found that through the restoration processes, we've been able to increase vegetation diversity. We found that we can reintroduce sphagnum moss, and it does grow successfully, particularly in the flow pathways. It's had an enormous effect on reducing the generation and sediment of transport, so particulate organic carbon, pieces of peat that are flowing in those channels. We've seen a rise in the water table back towards the surface, which is what we would hope to see, as this habitat type needs to be waterlogged in order for the peat to start forming again. We've seen soil moisture increases near the surface as well, and we've also seen some big natural flood management benefits. And I'll talk you through some of these things very briefly now. So that's what this experimental catchment looked like before the work started. So we've just got these, this is a V-notch weir for monitoring water flow, and some geotextile on the banks there of a gully. So that's an erosion gully. And then after 11 years or so, this is an image of the same spot from above. So you can see this big river of sphagnum that's flowing down this, and lots of vegetation on the sides of that gully. So it's had a profound effect on the way that gully behaves in response to storms, for example. And here's a picture of some of the undulating flat ground on the tops of where the gullies are. And you can see in just a few short years, we've gone from sort of, well, quite good vegetation cover compared to the bare peat, but then once those sphagnum plugs have gone in, they've really done well on this site. This is the expansion of sphagnum that we've recorded on that site. So we've got year 0 here, and then after 4 years after initial treatment, you can see the sphagnum on the hill slopes is now up to around about 30%, and the sphagnum coverage in those flow pathways is now getting on 90 plus, close to 100% in places. And the result of all this is that we've seen that slow and steady rise in water table, and it's still rising now. And that vegetation cover is increasing the moisture near the surface of the bog. And this is one of my favourite slides. This is the effect on the storm hydrograph. So we've measured that flowing through those V-notch weirs compared to a control. So you can see before restoration, these are our 3 different sites. So black is the control site where we've done nothing. The green is a site which we revegetated, and the N is our sort of our best condition site where we've revegetated and put in gully blocks and lots of sphagnum. And you can see the shape of the storm is very, very similar. But after that treatment that I've showed you, this is how they respond to storms now. So you can see the flood peak is really flattened out on the treated sites, and the lag time between the peak of the rain and the peak of the storm is a lot later. So when we last did the calculation, which was a few years ago now, in 2021, we found that had a 67 percentage point reduction in the peat discharge into the waterway, and the lag time had increased from a 30-minute in the baseline period to 200 plus minutes in the treatment catchment, whereas it remained at around about half an hour in the control site where we did nothing. And then the final thing I wanted to touch on really was the effect of all this work on sediment generation and transport. So this is one of the sediment traps that we've deployed in these gullies, and you can see all that bare peat. You can imagine how easily it's mobilized by freeze thaw or rainfall, or even drying out and being blown by the wind in summer, ending up in these channels. And what we found after an initial study that was 18 months after that treatment, there was a 97% plus reduction in the sediment generation and transport. So the green one again there is the revegetated catchment, and then the N is the revegetated with gully blocks and sphagnum. And that was only after 18 months. We repeated this back, I think it was 2020, and this is what we found. Oops. So after 50 days, the control site had captured 10 grams of sediment. The revegetated was 0.21 grams, and the best condition catchment was 0.01 grams. So basically nothing. There wasn't enough material to perform loss on ignition to calculate that carbon. So it's basically 99.9% reduction is what we've concluded from that. So you can basically switch off that flow of sediment into the catchments. So we know that, just to summarize what I've said before, the vegetation cover increases and thickens, that generation of sediment and transport stops, the sphagnum cover increases and thickens, the water table rises, and the near surface moisture increases, and that is creating a positive feedback loop, particularly in terms of the surface roughness affecting that storm flow. We've plotted out our trajectories of change here. So you can see there we've got erosion being a sort of step change in erosion and peat discharge. We've got a decrease in bare peat, increase in vegetation and indicator species, increase in lag time, and steady slow increase in water table. What we haven't yet detected a big change in is dissolved organic carbon in the water, so as opposed to the particulates. And that's something we're still looking into now. Part of the reason maybe is that DOC has increased everywhere during this time as a result of global changes to atmospheric pollution. Also, we only tend to take our samples in low flow, so we're about to do some continuous DOC sampling, hopefully later this year on that site. So that's one to watch, and everyone's very interested in that. But I'm now going to hand over to Alice, who's going to talk a little bit more in depth about water quality and the work she's been doing on a different area of peatland at Coombs Moss. So I'll hand over to you now, Alice.
Hi, sorry about that. Yeah, so I'm going to go through some of the stuff we've done at Coombs Moss, which is a site that Moors for the Future restored back in 2023, and it's been monitored through Moors for the Future and Derby University. So a quick point on sort of the water quality before I go into the site and case study. So intact bogs should naturally improve water quality, as sort of Joe's alluded to. The stuff that I'm going to cover in my section is going to be more on dissolved organic matter. So that's sort of the dissolved organic bits of it. So the nitrogen and carbon, and how that has responded to peatland restoration, specifically re-wetting. Next slide, please, Joe. Yeah, so the site that this work's been done on is Coombs Moss, which isn't actually, even though it says on the slide, it isn't actually in the Peak District, as I saw on Joe's map. It's sort of the national park sort of skirts around it. But it's an example of an upland blanket bog in Buxton, 475 metres above sea level. There's the coordinates there if anyone is interested, would like to know more. And so it's a plateaued top hill. So if you think of like a tabletop, so it's a steep ascent and then it sort of flattens out. And because it's flat and high elevation at the top, that's how peat can accumulate. Next slide, please, Joe. So the site was restored as part of the More Green Investment project. The map on the left shows you the different restoration interventions. So a lot of work was done on the site. So 187 hectares was planted with plug plants. 1,858 dams, 1,456 meters of reprofiling and bunding on 37 hectares. So how this site was monitored, so to basically build an evidence base for sustainable management of peatlands and to see, are the interventions having the desired effect? A BACI, so before after control intervention study design, was set up with an 18-month baseline data set basically gathered. So the before after control intervention design is where you have your baseline and you have a control. So the control site, nothing happened. And the other three, so we had a bunding site, a gully bunding and sphagnum plug planting, gully blocking and sphagnum plug planting, and then just a sphagnum plug planting site. So we can see the different hydrological interventions and how they're affecting the site. Next slide, please, Joe. So just to give you an idea of what we're talking about, these are some examples of plug plants. For those who don't work in the sector, it might sound a bit of a confusing concept. It's basically micro-propagated sphagnum. So sphagnum is the bog builder, the ecosystem engineer of a lot of our northern blanket bog. So the image on the right is a plug plant after 18 months in situ. So it's grown massively. And on the left is plug plants that we've put in for a new study that we're doing, which I won't go into because it's not particularly water related, but just showing how they grow, and basically the goal is for them all to coalesce, where the individual plugs will then form a big lawn, or with the sort of overall goal to be to sort of have a hummock hollow mosaic returned, eventually. It'll be quite a few years from now. But so that's plug planting, and we have one site that just has plugs. And then the other two that have interventions also have plugs and hydrological restoration. Next slide, please, Joe. So I will now touch on hydrological. Next slide, please. So unlike the examples that Joe went through, Coombs Moss was vegetated before restoration, so it wasn't a bare peat site, so it wasn't as catastrophic as the examples that Joe went through. But what it was dry. So peatlands, perhaps the reason why they basically accumulate is, as Joe mentioned, accumulation, which is through primary productivity, exceeds decomposition, and that is in part due to the fact that the water table sits at surface level, so that inhibits aerobic, so with oxygen, aerobic decomposition, which means that it's sort of, it locks in the carbon. So one of the objectives of the site was to restore the hydrological sort of regime of the site into a more near natural, sort of near the surface water table. One way that was done was through gully blocking. So gullies are erosion features that form through the passage of water. So it sort of scours out the landscape and basically work as like motorways for water to leave site. And as they scour, they're pulling, all the peat sediment and, eventually getting deeper and deeper. So in terms of water quality, it's a big export for carbon from the site. So the two pictures here are examples of gully blocking pools that formed on Coombs Moss. You can see our water sampling bottles on the image on the left. So what happens when you block it? So you use a peat dam where you basically, it's like a mass of peat put in the gully, and then the water accumulates to one side of it, preventing it from continuing down the gully. And eventually it'll revegetate, as you can see on the right, which is Sphagnum cuspidatum, which is the aquatic sphagnum species, has sort of recolonized the pool, and eventually sort of vegetation succession will occur. Next slide, please, Joe. So the other hydrological restoration technique used on site was bunding. So here is two examples of bunding, different types of bunding. So the one on the right is an example of scallop bunding. So it's sort of a semicircle crescent moon shape, and that sort of traps water through overland flow that would otherwise be sort of leaving the site. And then the one on the left, which is the one that I've been studying more, is an example of contour bunding, where you follow the natural contours of the site, and in a similar way, this sort of very narrow sort of mound of peat that goes around, so it's a structure like that, it will trap the overland flow, and then sort of increase the the water table depth, so that it's basically accumulating. Next slide, please. So a lot of monitoring has occurred on site. So it goes, beyond the water quality work that we're going to be discussing today. So hydrology, biodiversity, greenhouse gases, water quality, and microbes. So one of the main objectives of the project is to look at the trade-offs with different ecosystem services, and seeing, with certain techniques, do you get beneficial sort of outputs from certain areas, but then you have to sacrifice that, the idea that you can't achieve all of those, and what basically trade-offs you're going to get with different interventions. So for my work, this all ties into the role of microbes in the carbon dynamics of upland blanket bogs, and how different restoration interventions are affecting that. So the water quality piece, which is the fourth one down, it was done in collaboration with Loughborough University. And we basically used their Shimadzu carbon analyzer to measure DOC, TOC, total nitrogen, and then POC was measured using fiberglass filters and loss on ignition. But I'm going to focus mainly on the dissolved organic matter aspects. Next slide, please, Joe. So this is just basically the experimental setup. So it follows the design of quadrat, dip well, gas collar, monitoring unit. So I'm going to be discussing dip wells later in the slide. But basically, for those who don't know what a dip well is, it's a way of measuring the hydrology of a bog, where you basically have a tube that goes down through the peat, and then it's basically hollows out the peat so that you can then have, and you drill holes through it, and the water will sit at where the water table is in the surrounding peat, and then you put an automated logger, or you can do it manually, and it will basically tell you what level the water table depth is sitting at. So because that was within the peat body, for the water quality work, we used the dip well setup, which is outlined in that image, as our basically way of sampling pore water, so peatland pore water. Next slide, please, Joe. So this water quality piece was done through winter of last year, so it finished mid-March this year. So this is all quite hot off the press, and it's sort of preliminary results. There's a lot more analysis that needs to be done. So how we did it was collecting water samples across the 4 catchments in, so it was the outlet weir. So as Joe showed, the outlet weir is where the storm flow is measured with the V-notched weirs. So we use that as the source of the outlet water. Dip well arrays we used for a source of the peat pore water. And then there was artificial pools on both the bunded site and the dam sites, so the gully block sites. And samples were taken from those artificial pool systems. So the artificial pools were a form of surface water, the dip wells subsurface water, and then outlet weir was just water leaving the site. And we could basically see how they've responded over a winter. So with storm events and high rainfall, it's thought that TOC, DOC, POC will increase and in response to hydrological events. We were quite limited on the fact that it couldn't be done annually. And unlike the other metrics, this wasn't done in a before-after control intervention design. So it's worth taking in these considerations when thinking about the results that we're going to go through. And one of the limitations with DOC measurements is that the cost of equipment required for the monitoring. So the long-term sort of monitoring data sets are quite limited, just because of access to equipment and things like that. So what we can see from the total carbon figures, so we'll start on the figure from the left, but for both of them, I'm not sure if people can read them too well. But basically the purple colour is plug plants, the light blue is gully blocking, the green is the control, and then the red is the bunding. So we do see the catchments are responding quite differently to the dissolved organic carbon responses to seasonality. So you can see on the dip well figure on the right, the bottom left, the right, so that shows that the plug plants are actually having significantly higher DOC and total carbon TOC than the other catchments. So it's indicating that there could potentially be a relationship between hydrological restoration and reduced DOC and total carbon. We can also see that there was a much greater variability in the plug planting site. And so the sort of range of values was much lower when they've had hydrological restoration done. So yeah, I'll go on to the next slide now, please, Joe. So this one is about the carbon nitrogen ratio. I'm not sure what everyone's background is, but carbon nitrogen ratio is often used in ecology as a way of making inference about decomposition. So when a carbon nitrogen ratio is higher, it usually indicates there is greater decomposition. A lower carbon nitrogen ratio suggests that the lower decomposition from organic material. And yeah, the fact that we're having a different response from the gully blocking. So if we go back to that bottom left, so from the previous slide, gully blocking had a much lower total carbon, sort of more in line with the other catchments, and we had plug planting as a significantly higher. But when you look at it in the carbon nitrogen ratio, it has that, and it's sort of almost on par with the plug planting site. So it's much sort of flashier. The response to sort of rainfall events, it looks like it's basically mobilizing either recalcitrant carbon deep within the peat body. So that could be one example for the carbon nitrogen ratio being higher. So within peatland decomposition, we have recalcitrant and labile carbon. Recalcitrant is much older and it's often found in the catatelm. For those that don't know much about peatland ecosystems, we have, if you think peat bodies go really deep down. So on this site, over 4 meters deep of peat. And the catatelm is that region of peat that is permanently saturated. So the water table, it sits below the water table, so it's saturated throughout the year constantly, and that's where you get your recalcitrant carbon. It's hard to decompose, hard to break down. The anaerobic microbes haven't managed to break it down, and then your labile carbon is much easier to decompose, and that tends to be sort of higher up in the peat profile. So yeah, the ectotelm is the aerobic bit where you tend to have easier to decompose carbon. So the interesting thing to take away from this one is that the gully blocking seems to be mobilizing some deep peat that basically is harder to decompose potentially. Next slide, please, Joe. So as said, this is a relatively new data set that we're working on. So it finished mid-March, but I've been basically modeling it to see what relationships we can pull out and where to go next with the analysis. So what we are seeing from a general linear modeling approach is that there does appear to be a relationship between restoration treatment and the dissolved organic carbon. So we're seeing in addition to that, the different hydrological sample types are also significant in that relationship. So the subsurface peat has much higher TOC, which is as we would expect. And we're just now looking at seeing whether we can decipher that relationship and seeing which of the restoration interventions are working in what way. So we are seeing significantly or consistently higher TOC in the plug planting catchment. Without having the baseline data, we can't really tell whether the other sites were at a similar level to plug planting before the hydrological restoration. But when looking at the baselining data for the other metrics that have been monitored, they were on sort of similar levels. But we can never say with any sort of certainty or that they were. So gully blocking as well, we're seeing responds differently to seasonal variation, and having that quite significant spike in the carbon nitrogen ratio, it looks like that is a response to high rainfall events as well. And we can basically say that it looks like restoration and hydrological flow pathway are influencing aquatic carbon. So next slide, please, Joe. Yeah, cool. So there is quite a few limitations to just consider when looking at this data set. So we only had one replicate for each treatment. So we only had one catchment. We didn't have the baseline data like the other metrics did. And sampling only covered one winter. So we don't actually have that full sort of annual seasonal variation, which in sort of low flow, which would be your drought seasons and things like that, the response will be sort of significantly different. And there's sort of a whole load of data that would sort of be really interesting looking at how it responds and how different hydrological restoration responds to that low flow event. So next slide, please, Joe. So as mentioned, this is a relatively new data set, and there's quite a lot of different things that I'm looking to do. So that image on the right is basically for each of the samples that got analysed for their dissolved organic carbon, dissolved organic nitrogen, I've also got suspended sediment. And as you can see visually, there's a huge difference in the suspended sediment. So I have a whole other data set, which is suspended sediment, which has been obtained through loss on ignition using fiberglass filters. So that's going to be included in the analysis as well. And then I'm planning to include our various other data sets. So for each of the sites and each of the sample points, we have dip well data for the water table depth. So we know exactly how the water table is responding. We also have the rainfall, the meteorological data, and then the storm data, so from V-notch weirs. So we can actually see what the hydrological, meteorological conditions were like leading up to those samples. So if you think about where in our data set we've seen significant spikes, we can see if that aligns with weather events, and sort of seeing if different techniques, restoration techniques, are causing less dramatic peaks and troughs, because that's what we would sort of like to see, is more stabilized figures for these water quality metrics. Cool. I think that's it for my set of slides.
Well, thanks very much, Alice and Joe, for some very interesting presentations. And thanks to Andrew that introduced the webinar at the beginning, who's the chair of the East Midlands branch of CIWEM. He's had to drop off, so I'm going to facilitate the Q&As now. So if anyone has got any questions, drop them in the chat and I'll go through those, but I'll just go through these CIWEM slides whilst you write in your questions. So CIWEM is going to be at the International Water Association World Water Congress and Exhibition in Glasgow 2026. Going to be in the UK Pavilion. So for anybody that's interested in going along to that in October, have a look into that, and there's going to be lots of interesting events and discussions happening there. So go to the next slide. And this is just a call for papers for the Journal of Flood Risk Management. For anybody that is interested, there's a QR code there to scan for more information as well, if you have any relevant papers that could be submitted to that journal. And then next slide. And these are a list of some of the up and coming CIWEM events. So as Andrew mentioned at the beginning, we've got an in-person East Midlands event, which is going to be a visit to the Sandy Acre Canal in Derby. That one's not quite been posted on CIWEM events, so just keep an eye on when that one appears to book onto that. There is the Flood and Coast Conference coming up on the 9th to 11th of June in Liverpool. There is a webinar around preparing for your CIWEM chartership, competencies B1 and B2, in the 16th of June. There's another in-person event at the Hornicote Estate, and that one is, if you look on the website to book under that. There is a rainwater management webinar for flooding on the 29th of June. And the 9th of July, a webinar about reservoir safety. And then if you go to the next slide, there's a few more as well later on in the year. Yeah, the Urban Drainage Group, that's an in-person event in Sheffield for new members. There's an Early Career Professionals Conference in London in September. The CIWEM Dr. Jenkins Award, which is a joint event between East Midlands and West Midlands. CIWEM is being hosted by West Midlands in Birmingham this year, the 23rd of September. So that should be coming up onto the CIWEM website soon. And then finally in December, there is an Urban Drainage Group annual conference in Birmingham as well. So that is some of the events. If you have a look on the website, there might be some others that appear on there as well. I don't think there's another slide after that one. So if we go to the Q&As, we've got a question for Alice from Yannick. How do you go about selecting the best sites for interventions like gully blocking and bunding?
So I think it would be good to get Joe's perspective as well on this from a practitioner point of view. But with peatland restoration, each site is sort of evaluated individually, you know, what are its stresses, what is the condition that it's in, and what needs to sort of change for it to be sort of restored to a healthier version. So there's back when I was working in Wales, we basically made a glossary of all the interventions, and there was over 100 different things that you could do to restore a bog. And basically you need to sort of have an idea of what its condition is and then tailor it, so have bespoke management plans and bespoke restoration plans based off what the issues are. So the ones that undergo hydrological restoration, they will have dropped water tables, they'll be a lot drier, which you'd sort of visibly see through having more sort of dwarf shrubs such as heather, so Calluna vulgaris, and it'll just sort of feel drier underfoot. And then you can do baseline monitoring to sort of see what the condition is and then design your plan around that. Joe, do you want to chime in there?
Yeah, haven't got too much to add, but just to say that we, as most of the future, would follow a similar process. So all the sites would be, first of all, identified from, I guess, from a desktop study, and then visited by surveyors on the ground who will look at the condition of the site. They'll look at things like how gullied it is, how extensive that network of erosion gullies is, what the composition of the vegetation is, and then, as Alice says, identify the basics that you need to correct before you can then move on to other things. So it's about removing those stresses is the first step. So things like blocking gullies to try and raise that water table and introduce vegetation where there isn't any. But if there is vegetation, then you might be looking to diversify it. or introduce missing indicated species, etc. So each site is looked at on an individual basis to try and identify what are the fundamental biggest problems. We'll try and tackle them first, and then we might go back again and try and refine it and add additional interventions.
Okay, thank you. We haven't got any more questions on the chat, but I've got a couple that I can ask. So for Joe, you showed the storm hydrograph of a gully. Have you got any plans to do any monitoring of a wider subcatchment to see the impact of like a number of gullies in one area?
So we haven't got any specific plans to do exactly that. What we do have is another 5 years worth of data from those catchments that I showed you, that we're in the process of crunching the numbers at the moment, so we can get an update after a further 5 years of maturation of those interventions. There's been some really interesting modelling work done, which has scaled up our interventions in that little mini catchment to the Glossop catchment. So this was done by University of Manchester. So basically taking our real world data and scaling it up to see what kind of effect that might have on a variety of different categories of storms. And it did have in the model, if you were to restore every piece of available peatland to the same standard as that catchment that I showed you, then it would have a very significant effect on flood peaks in both big and small storms, looking at some big return periods as well. But no, I mean, and there's interesting questions to be asked about catchment synchronization when you put in interventions in. But I guess one of the main reasons we haven't scaled it up yet is it's difficult to find the sites to do it, particularly ones that have got a bare peat control left, because we've done a lot of work everywhere, and also it's incredibly expensive to do this kind of monitoring over the long term, which is what we need to do. So we've been very fortunate in being able to keep those data sets going for a long period, 15 plus years in some cases.
Yeah, that's great, thank you. And then a question for Alice. So you started your monitoring in December. Do you think if you started it earlier and you captured, say, like the first rainfall events of the winter, that might show some interesting results, especially perhaps after the very dry summer that we had last year?
Yeah, definitely. So there's this theory about flushing post-droughts. So when you get sort of return to normal rainfall after a drought, you get sort of spikes in DOC. The reason that the data set started in December, so it was funded through a grant, the ITSS Equipment Sharing Grant, and within that it allowed for 300 samples in total, which meant that it was limited temporally. Originally I wanted to do it for 18 months, but I wasn't sort of able to get the funding for that. So I decided to go through that winter period to see, because that's when we were getting sort of more extreme weather, and sort of seeing how it's responding to heavy rainfall. And I think it's sort of quite good sort of pilot data for this sort of monitoring to be done on future sites. But as Joe said, this sort of monitoring is quite cost prohibitive, and there's definitely a focus on sort of getting sites restored than monitoring. I think that's a national sort of sentiment in the peatland sector. But then to understand what's happening and whether the things we're doing are working, you do need to monitor. So it's trying to strike that balance between proactive, on the ground, grounds work and monitoring. So I think, yeah, MORS for the future partnership are really sort of steering the way, is that the correct term? For this sort of monitoring to be done alongside restoration.
Okay, great. Thanks very much, Bev. There isn't any further questions, so yeah, I just want to thank you both again for an interesting presentation, and thank you everybody for attending this webinar on the science of upland peatland restoration, hosted by CIWEM East Midlands branch. We hope you found it interesting, and you'll join us again for any future webinars, and have a look on the CIWEM events page to find out more about those. So yes, thanks very much, everybody.